Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to talk about the synthesis of alkyl halides using the NBS reagent. So here are the important things to know. First, it provides a controlled way to generate alkyl halides. Using NBS, which is this structure at the bottom of the basic section, is a way to generally arrive at alkyl halides in a more controlled way than using the radical chain reaction mechanism. Remember that when we do the radical chain reaction mechanisms, having that initiation, many propagation steps, and a termination step can offer and give a lot of products, which is something that competes with the main objective, which is to create the desired product as efficiently as possible with as much yield as possible. And so using NBS is key to generating really a small concentration of bromine, molecular bromine, which can then go on and react with the alkanes and afford those alkyl halides. So here's how the reaction works. So the initiation step involves starting with NBS and irradiating this with light. And when you irradiate this with light, the nitrogen-bromine bond breaks in a homolytic way. This is the most this is the most reactive bond on the molecule. So you use the fishhook arrows and you arrive at this radical. Plus the bromine radical, okay? So this isn't really a propagation step. This is just another initiation step that's happening at the same time, right? So now in a propagation step, so now the bromines can recombine to make molecular bromine. And then this molecular bromine can then undergo an initiation step. To react with an alkane in a propagation step. Forming this primary radical. And then the other bromine radical can then come in a termination step. And effectively halogenate this propane to afford one bromopropane. This mechanism describes how we first generate molecular bromine, and then bromine, now that it's formed, can undergo this more controlled reaction. And the reason that this is more controlled is because the NBS itself first has to react to generate the bromine radicals, they combine, and then with this relatively small concentration of bromine radicals, this can then go on to brominate this alkane and any other kinds of alkanes that we've discussed in class. Okay, and finally, we have a few questions that we can ask during office hours that I could think of. First, are there any other halogenating reagents that can give a similar control on alkane halogenation? Two, are there any substrates that are not reactive with NBS, that aren't compatible with NBS? And three, what type of light do you need for this reaction to actually go, to break that nitrogen-bromine bond? Do you need ultraviolet light, visible light, infrared light? Those might be interesting questions to ask during office hour. So with that, this has been Organic Chemistry in 5 minutes or less. Thanks for tuning in.